Hello and welcome to my channel. My name is Abdul Wahab. This is going to be my first YouTube video, and I'll be using Fluke Energy Analyze Plus, which is a software developed by Fluke, which is compatible with their new Fluke equipments, mostly the power quality analyzers. And we'll be looking into the details of studying harmonics. You can find plenty of websites online where you will be able to figure out how to study the load demands, the volts, amps, hertz in your system, but you rarely find any video discussing how to study the harmonics in your system and what kind of conclusions can we draw while looking at the harmonics graphs. So without any further ado, let's just jump into the video and start looking at the data. So Fluke Energy Analyze Plus 3.1, and the equipment that I was using in the last power quality study was Fluke Power Quality Analyzer 1777. You could get the similar results with other Fluke equipments, but as of now I'm just using Fluke 1777 Power Quality Analyzer, which I think is the most advanced and the recent one from Fluke. So basically the purpose of doing this video is to explain in detail how to study the harmonic levels, how to figure out if active harmonic filters are required on your site, and what kind of negative impacts can harmonics have on your system. So let's just start. This is a study done in one of our facilities. It was a medical facility, like a healthcare center, and let's just go to these settings. So this was a power log data done for 3 days, 16 hours, 34 minutes, and our settings were basically very simple. I was using 6000 amps flexi clamps, and let's just go to the dips and swells. The settings were, for the dips were set at 90%, the swells were set at 110%. And basically I was recording power quality harmonics, 3-second harmonics, 3-second interharmonics, supra harmonics, and 100 harmonics. So let's just start with the energy study. Once you open this, you will see a basic chart wherein you can find volts, max, linear average, and minimum. So this basically gives you the overall idea of what kind of voltages are present in your system. Now for us, the end user was complaining that they are having voltage fluctuations in their system, and they have been trying to study this for a very long time. They had some nuisance trippings, they had some final distribution boards burning out, they had some biomedical equipment not working properly, and regular failure of electronic equipments. So once we look at this, so AN means your voltage reference between phase 1 and neutral. The part I'm from, we call it red phase. So basically red and neutral, then yellow and neutral, and then blue and neutral. So basically it's just phase to neutral voltages. So let's just stick to the red phase and have a look of what this is trying to tell us. So the maximum voltage recorded during the 3-day study was 233 volts. And the linear average was 228, but if you look at the minimum, you see that the voltage, there was a significant dip when the voltage came to 202 volts. Similarly, the current graphs, okay, you can go and look at the current graphs, the frequencies, the voltage total harmonic distortion, the amps total harmonic distortion. In about a minute or so, I'll be going into the percentage levels. I'll be discussing this in detail, like why we can't rely on these values. Okay, so let's just go to the graph for a second, and from here we go into the volts, A, B, C, and neutral. So I've already searched for the maximum and minimum values. So once you go through all this graph, you will be able to figure out like where the max and the minimum voltages have occurred at what time, at what date. So this is important for us, right? And what I try to look for is go into the current graph and look at the maximum and minimum values. So this was my network, okay? And if you look at, let me just move this, okay? So if you look at the maximum current values, you'll be able to see that the max current has almost occurred at the same time. You see 1204, 1158, 1204. And the minimum that has, you know, that is almost at the same time, I would say, for the red and yellow phase. But for the blue phase, it has, you know, there is a significant time difference. Now I will you know, try and explain why this is important. So once we go to the power quality study and we look at our graphs, okay, and from here we select the harmonics, okay. So just give it a second to load. And this is a big file, so it might take some time. Oh no. Okay, here we go. So let's start with the RMS values. The good thing with this equipment, like Fluke 1777, is that we, instead of looking at just the percentage fundamental values, you actually get to see the actual current the harmonics are drawing. And if I go into the graph right over here, so this is app harmonics, okay. So let's just look at the total harmonic current that our system had, okay. So these are the three phases, red, yellow, and blue. And once you just, let me find the max and min values over here. So see, this is what we see. Let me just move this, okay. Okay, and then just move this one over here. Okay, so what we see over here is that our harmonic current and is basically going to, if I move this cursor and I select red phase, okay, so our red phase is basically indicated by the black line that we see over here. And if I move the cursor, I can see the values in this particular window, cursor 2. And if I go to the max values, I can see that the max total harmonic current of 50 amps was drawn at 10:20 a.m. and the date was 8/6/23. So why this is important is we cannot just say that the max total harmonic current or a filter of active filter is required of 50 amps. We can't rely on this data. We have to go and study this in detail. So what we see over here is the max harmonic current or the total harmonic current was drawn at 10:20/806. Okay, so let's just jump into the energy study. And once again, I'll be bringing in the cursor. And as of now, we're just looking at the red phase. Okay, so let's just select the red phase and sorry. Okay, so we had the time of 10:20 at 8:06. So just looking at the same window, cursor to 10:20. Okay, so I know now that this is the part where you know, the maximum harmonic current has come. So let me just zoom into this part only. Okay, now it'll be much easier for us to scroll through. So no, one sec. Okay, once again. So now we're okay. Let's just keep using the cursor too. Okay, and 10:20 is somewhere over here, right? So let's just zoom into this part once again. Keep using the same cursor. No, it's on the 9th, so let's just move back. So right about somewhere over here. As of now, I'm at 10:21. Okay, and let's just jump into the power quality once again, just to make sure that we're at the same time. So it was 10:20 a.m. sorry. So let me just pull this up again. Okay, so 10:20 a.m. Let's just zoom to the auto scale. 10:20 a.m. So 8, and then just go back. So this is the region where we have the maximum flow of current. Let's just zoom into this, and let's just scroll back. So what we see over here is at almost 10:20 we had a current of 414 amps. What you can do is further zoom in to scale it easily, and then once we go to 10:20 we see that the maximum current that our system was drawing was 423 amps roughly. So why this is important, let me just zoom out once again and load display all the um, three-phase currents. So what we see over here is that the maximum current that our system has drawn was 670 amps in the blue phase. Okay, why this is important is when looking at the power quality study, we tend to look at the harmonics value when our system was drawing the maximum possible current, right? So what I do is I know the time when my blue phase was drawing the maximum current, which is 11:58 a.m. The date was 7/6. Now I jump into the power quality study, and since this was just the blue phase, let me just open up the total currents. Okay, so blue phase, and the blue phase is referred to as C over here if you follow my cursor, and let's just move cursor. So it was 11:58 a.m. on 7, right? So right in this part, right? Let's just zoom in. Okay, so again, once again, 11:58 a.m. So this part, right? If you look at this now, you see that the total harmonic current was only 29 amps. And if I just, try and set this to 11:58, right there. So it's just 28.52. Now the problem with this is that even though our overall, if I zoom out over here and I see the maximum values of 50 amps, what my power quality study is telling me is that even though the maximum total harmonic current reached up to 50 amps, still, at the maximum load, the demand load from our system, the harmonics current has balanced out at 29 amps. And this is important, if we go to the energy study and if we look at the maximum current or the average current. Now, this is important, you see, the average currents were 459, 399, 453. So what this means is that my system was basically fluctuating around between 450 to 400 amps. But the maximum it has reached is 761, 798. Now these are values recorded separately, so you might not be able to see those in the graph, but that does not affect our calculation of harmonics. Now the second thing which is most important over here is we've already figured out that our average current is 450, right? The demand. Now, once I go to the power quality study and I look at the harmonics graph, right? And let's just go to the total. I like working around the total harmonic current. So what we see over here is that our max 50 and our lowest possible harmonics current was 24.2, 25.29, okay? So basically what this tells us is there are harmonics in our system, and if I go using the Fluke Energy Analyze and if I go to the power quality head, and basically we did this study using IEEE 519 2014. Now here is where it gets tricky, you see. Basically while starting the test I had set my IL and the short circuit current. Okay, so my breaker rating was 2500 amps ACB and the short circuit current was 65 kA. Now the problem is, if you look at the current harmonics, okay, mostly order 3, it is showing me results of pass, 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 because it is taking the percentage of my harmonic current, okay, which was 50 or 25 or 30, based on this value. So if it is taking the percentage of 2500 amps and the harmonics current was only 50, the maximum that we had recorded, the percentages will be very low. This does not mean that we don't have harmonics affecting our system. And the basic reason is, see, even though the breaker was 2500 amps, this does not mean that our harmonics current were only 1.63, 1.1. We have to look at the fact that our system average current was 450, as I discussed before. And if I look at the max values, I have stopped at around 800 amps. So looking at these values, our maximum current should have been set to 800 amps or 900 amps. We can't keep it to 2500 amps and look at the percentages. That will, all our results will be based, if those are based on 2500 amps, the recordings are, or our calculations are wrong then. So why this is important is 2500 amps set during the testing period when we installed the power quality analyzer on our site, and we saw that the main incoming breaker was of 2500 amps with 65 kA short circuit current. Even though the incomer rating was 2500 amps, that does not mean that the total demand is 2500 amps or the maximum current that your system will go to is 2500 amps. This just means that the total connected load is of 2500 amps. It does not mean that all the loads are running at the same time. Okay, so why this is important is you cannot rely on this data to figure out the percentages and tell your client that you don't have any harmonics issue. That's not the case as far as I know. Okay, so now the last and the most important factor over here is, based on this data, it's very easy for someone to select an active harmonic filter and to decide whether it is required or not. I'll be going into what active harmonic filters are and what detuned reactors are, what capacitor banks are in my coming videos. But as of today, just look into this, that see, we have got harmonics of 50 amps. And if I calculate the percentage based on 50 amps and the linear average of 450, then my percentages go significantly higher, right? And if I calculate it on 800 amps, which the power quality analyzer has recorded, and this is probably the peak value, still my percentage will be significantly higher as compared to 2500. So guys, we can't rely on keeping our IL as 2500 amps, because that's not the case. My system is not drawing 2500 amps, right? The maximum value that it has reached is 798. So I might, keep a significant buffer. So let's say I can assume 900 amps would be the maximum load running at a particular time, but I can't keep it at 2500. Okay, now the last important thing that I'll be discussing in this video is once you go to volt amp hertz and you see over here that our neutral has 192 amps of max current and the linear average was 100 amps. This is very high. This is extremely high. And what you see over here is most of our loads are balanced. This also implies that probably most of the connected loads were three-phase, and we did not have much of single-phase loads in this particular distribution board. So let me just jump into the graph, okay, and let's just switch off the phases and just turn on the neutral current graph. Now what we see over here is that maximum neutral current reached up to 148 and the lowest value was 73. This is too high. Our neutral shouldn't be carrying this much current, especially if the system is balanced, right? If it was unbalanced or single phase loads, yes, this is normal, but if it's a three-phase balanced load, no, this is too high. So now we have to figure out why our neutral has such high values. And once we go to the power quality study, right, And let's just look at the neutral part as well, right? So what we see over here is our neutral is also carrying the harmonics. The harmonics are also flowing into the neutral, right? Now this is important. Once I've turned on neutral, what I'm going to do is I'm just going to look at the total harmonic current in the neutral. And wow, once we go into the neutral, we see that our harmonics current are 105, right? 101. Okay, now once again, how we do this is very simple. We just go to the energy study. We'll look at the maximum, the time wherein the current was at the maximum. So it's 10:08 a.m. The date was 8/6. Again, 10:08 a.m. Right, on 8th of 6. So let's just go into the power quality study once again. 10:08 on 8, right? So let me just drag this to the side and let's just use, okay, so we are using cursor 1, right? So let's just go to this part, then 10:08, right over here. See, our maximum neutral current was 28.2 recorded at the time when our neutral was carrying the highest current. Okay, and sorry, this is not the total. Let me just go into the total one right here. So 10:08. So basically I know this is the part, so it helps when you zoom in, right? So right about here, 10:08. So see, now you can see that the total harmonic current in terms of amps was 72.27. Now just looking at the phases, we had figured out that the maximum total harmonic current was 50, right? But once we look into the neutral part, we see that the maximum amps have gone up to 72.27 when the current was at the maximum value. So what this tells us is that we definitely need an active harmonic filtering in this site. And while considering the total, the active harmonic filter, we have to keep in mind that we just don't use a 3-phase active harmonic filter. We have to use a harmonic filter with 3-phase and neutral. If we just use a 3-phase harmonic filter, it's going to suppress the or cancel out the harmonics in all the 3 phases, but not the neutral. And neutral is a path where most of our harmonics are flowing. So what this tells us, again, to summarize, at first, while looking at the amps, we figured out that most of our loads were 3-phase. But let me correct this. Most of our loads are not 3-phase. Most of our loads are single phase. And why do I say that? It's because of the harmonics current flowing in the neutral. Yes, those are balanced, but still, once you see such high values of harmonics in your neutrals, you can reach the conclusion that most of your connected loads are single phase. Okay, so that's it for today. This was just my first attempt on discussing what are harmonics, how to go into the details. I would really appreciate if you guys put up your comments and let me know if my approach is wrong or if it's correct or if it has helped you in studying your power quality system. And if you guys like this or if I have helped you in any way, please, I request you to subscribe to my channel, hit that bell icon so you keep getting notifications of my upcoming videos. And that's it. Have a wonderful day. Goodbye.